Today, we are going to pull back the curtain on the invisible rules that keep our digital lives from just completely falling apart. We're talking about the fundamental principles of operating system protection. You know, the stuff that makes everything you do on your computer not only possible, but safe. So let's just kick things off with a simple question to get you thinking.
Seriously, just think about that for a second. You download what you think is a simple game and boom, it immediately starts digging through your emails and deleting your family photos. That sounds like a nightmare, right? Well, without a set of strict rules enforced by your operating system, that would literally be our reality. And that is why we need protection.
Okay, so first things first, why do computers even need all these rules? I mean, can't the programs just behave? Well, no. Without them, programs could accidentally or even maliciously interfere with each other. They could corrupt your data, crash your machine. It would be total digital anarchy.
And that brings us to the main goal here. At its heart, operating system protection is all about one thing: controlling who can access what. It's about managing access to all the computer's resources. We're talking files, printers, memory, you name it, just to make sure everything runs smoothly and, of course, securely.
Now, listen up, because if there is one single idea you take away from this entire explainer, I want it to be this one. This right here is the guiding philosophy, the North Star, for building any secure system. It's called the principle of least privilege, and it's actually a really simple idea. Think of it like this. You give a valet a key that only starts the car and opens the driver's door. It doesn't open the trunk, it doesn't open the glove box. A program, just like that valet, should only get the exact permissions it needs to do its job and absolutely nothing more. Let's see how that actually plays out. With least privilege, your photo editing app only gets access to your photo library. That's it. If it has a bug or gets hacked, the damage is contained right there. But in a world with maximum privilege, that same bug could let an attacker read your financial documents or install malware. See the difference? This simple principle basically builds a wall around potential disasters.
To make it even simpler, you can just think of it as the digital version of the need-to-know principle. You know, like from spy movies? You only get access to the information that is absolutely essential for your mission. It's a really intuitive and powerful way to think about security.
Okay, so we know why we need protection. But how does an operating system actually do it? Well, the whole system is built on this foundational concept called a protection domain.
So what's a domain? It's basically a bubble of privilege. It's just a collection of access rights that spells out what a particular user or a process is allowed to do. You can kind of think of it like a job description. It defines your responsibilities and what tools or resources you're allowed to touch.
And believe me, this isn't just theory. In a system like Unix or Linux, your user ID, that is your domain. But what happens when you need to do something powerful, like install software? That's where a command like sudo comes in. And this is so important because you don't want to be running around with godlike admin powers all the time. It's just way too risky. Sudo lets you temporarily jump into a powerful domain for one single command, and then you immediately drop back down to safety. It's a perfect real-time example of least privilege in action. So, domains are like individual job descriptions. But for a whole company to work, you need an org chart, right? A master blueprint that shows who can do what. For an operating system, that blueprint is called the access matrix. The access matrix is this beautifully simple model. It's basically just a grid, a table, that clearly and logically maps out every single permission in the entire system. It answers that fundamental question of protection. Who is allowed to do what to which resources? So here's what it looks like. You see the rows? That's the who, our domains. And the columns are the what, our files, our printers, all that stuff. And the little cells, they tell us the rules. So, for example, just follow the row for domain 1. You can see it's allowed to read file F1 and F3, but if it tries to touch the printer, nope, access denied. Simple as that. But wait, it gets even more powerful. The matrix can have special rights. The owner right, for instance, lets a domain change the permissions in its own column. But control, that's the big one. Control allows one domain to change the rights of another domain. This is how you create system administrators, right? You give them the power to manage the rules for everybody else. So that matrix model is great in theory, but storing a giant, mostly empty table isn't very efficient for a real computer. So in practice, operating systems implement this idea in one of two main ways. The first approach is an access control list, or ACL. The best way to think of this is like a bouncer with a guest list standing at the door of every single file. That corresponds to a column in our matrix.
The second approach is a capability list. This is like giving each user a keyring that holds all the keys to the doors they're allowed to open. And that corresponds to a row in our matrix.
Now, let's say you need to kick someone out. You need to revoke their access. If you're using ACLs, it's incredibly easy. You just walk up to the file's guest list, find their name, and cross it off. Bam, done. Access is immediately gone.
But with capability lists, oh, it's much, much trickier. Think about it. The keys have already been handed out. You can't just easily take them back. So how do you revoke access? Well, you have to use these complex schemes, like reacquisition. That's basically like changing the locks on the entire building every week and making everyone get new keys. Or indirection, where the key doesn't open the door directly, but first has to be checked against a central master list that you control. As you can tell, it gets complicated fast, and this really highlights a classic trade-off you see all the time in security design. All right, let's wrap up with a quick look at a more recent development. See, protection isn't just the job of the operating system anymore. Now it's being built directly into our programming languages. This is a really big shift in thinking. Instead of relying only on the OS to be the big referee for everything, the programming language itself can enforce the rules. This lets you get way more detailed and fine-grained with your security right inside the code. And a perfect example of this is Java. The Java Virtual Machine, the JVM, it acts like a security manager. When code is loaded, the JVM assigns it to a protection domain with a specific list of permissions. Then, if that code tries to do something sensitive, like access a file on your computer, the JVM steps in and checks its permission slip to make sure it's allowed. It's like a security sandbox built right into the language itself. Pretty cool. And that brings us to our final thought. From your smartwatch to your smart fridge, everything is a computer now, right? In a world with billions of interconnected devices, each one a potential vulnerability, does that single, simple rule we started with, the principle of least privilege, become the most important concept for building a secure future? It's something to think about. Thanks for joining us on The Explainer.